Aryava, Wakil Duta Besar Amerika Serikat di Indonesia. Menyambut datangnya bulan Ramadan, saya mendoakan keberkahan selama sebulan penuh bagi semua yang menjalani. Di saat-saat penuh ketidakpastian dan kecemasan yang sedang berlangsung saat ini, saya terinspirasi oleh berbagai kisah mengenai harapan, kemanusiaan, dan kedermawanan yang tak terhitung yang kita miliki bersama. Semoga bulan ini memperkuat persahabatan kita. Selamat menunaikan ibadah puasa.
Hello everyone and welcome back to Ed America TV. My name is James, one of the e-guides here at Ed America, and we welcome audience members joining us online. We hope that you're doing well and staying safe. Ed America is the United States Embassy's American Center, and our mission is to provide a space for young Indonesians to learn more about the United States. In this episode, we'll be having Earth Optimism for Educators, My Career in Conservation and Designing the Future. But before we begin, let's break the ice with a little game. I have here a question for everyone. True or false, 200 gallons of waters are wasted every day by average home users? Stay tuned until the end of this program because we'll be giving a live shout out to whoever can answer correctly on our social medias. I'd also like to let everyone know that as continuation of Ed America's 10-year anniversary celebration and Earth Day in April, we are holding an activity along with several giveaways. Those giveaways are 5 bicycles for 5 lucky people. And if you're interested in joining, stay until the end of this program to find out more. Other than that, don't forget to take a selfie and tag at America's Instagram account. And now, without further ado, let me introduce everyone to today's moderator, Mas Johannes Lameri, a YCLE alumni and Master of Arts candidate in Social Enterprise from the American University. Mas Johannes, the stage is yours.
Thank you so much, James. Good morning, good evening, good afternoon for everyone. Welcome to the last series of Earth Optimism for Educators. I cannot believe that we've been together for 5 weeks, and this is like the last series of Earth Optimism for Educators. And happy Earth Day. This program is designed for teacher, activists, practitioners in education for sustainability and conservation field. Great to see you all, and I hope that this session will make your Saturday night become more meaningful. And thank you so much for everyone who joining our discussion today from different places in Indonesia or the world. So my name is Johannes, joining from Washington, D.C., and a grad student here at the American University. And today's theme, we're going to talk about career in conservation and designing your future as a future conservationist or someone who would like to work in conservation field. So in today's discussion, we will hear from Smithsonian experts where they will share the details about their career paths and conservation efforts, including using digital technology in creative ways. Together with us in our session today, we have a full house. We have 4 speakers: Daniel, Jessica, Cody, and Autumn Lynn. And I'm excited to welcome 4 of you. But before we begin our conversation today, I'd like to open with a short video about the work of Smithsonian Institution. Please enjoy.
America, 1846, an audacious idea to grow and broadcast more knowledge than the world had ever seen. With an eye to the future, that dream was the Smithsonian, your Smithsonian. Expanding the portrait of a people, revealing the building blocks of life, to discover new species and save those we already know. A knowledge powerhouse with purpose and a community mindset. Inspiring a new generation to learn from the past. Speak up. Be civic. Serve a nation. So that together we can step into the future with optimism dreams deferred.
Thank you so much for the very great video. So before I introduce our speakers today, I have a couple of announcements like usual. First, regarding the certificate, we do have certificate only for those who participated in 4 out of 5 Earth Optimism for Educators sessions. So if this is your 4th or 5th, congratulations for getting those certificate. And if you guys have question, please use the chat box to ask your questions and we will read it to our speakers. And for our speakers today, please use the chat box to interact with our participants who are joining from different part of the world tonight, this morning. Now, I would like to introduce our first speaker today, Dr. Daniel Lumbantobing. But before he present his presentation and talk about his career in conservation, I would like to read his bio. So Dr. Daniel Lumbantobing is a postdoctoral fellow in the National Museum of Natural History Department of Vertebrate Zoology or Fishes. He studies the systematics and taxonomy of these groups of fish using both morphological and molecular analysis. Wow, those sounds very complex and very interesting terms. One of his major interests of studies is
Lights now?
yes, please.
Okay. Thank you, Johannes. All right. Hello, everyone. Good evening to all of you. I'm Daniel Lumbantobing, and as you can see here, a lot of fish pictures. So I basically study fishes, and I'd like to introduce you with all the fishes that I study and also what I've done for their conservation.
Daniel, one second. I'm not sure if I can see your share screen yet.
Oh, okay. Sorry about that.
There you go. Perfect.
Okay, so you can see now.
Yes.
All right, sorry about that. So yeah, I will introduce you with the fishes that I've studied and also the conservation that I've done for these fishes. So my field of expertise is taxonomy and systematics. I focus on freshwater and estuarine fishes, and those fishes are mostly from Southeast Asia. And for my research, I use specimens in Natural History Museum. So here, as you can see, there are jars with fish specimens, and I do a lot of observation using microscope, and this for the morphology part. So what is taxonomy and how it can be applied in conservation? So in a nutshell, taxonomy is all the scientific activities that has anything to do with the identity and the classification of a living organism. So basically, every day we see a diversity of living organism, and in order to be able to communicate and to work on this creature, we need a scientific name. And this is the Latin name that usually we use in a global extent. and how do we know the name of the species? We usually use unique characteristic to diagnose the species to determine whether they are different from one species to another. Also, as a taxonomist, I provide all the data crucial to identify the species and to classify them. And in addition to their unique characteristic, we also need other data, which is the ecology. Something like where can we find the species, in what kind of habitat they are, and what ecosystem that suits these species. So that's also part of my study. And also what is important is about the distribution of the species, the geographical range that you can find the species. And once we gather all this data, then we can assess the conservation state of the species. Of course, that makes that the real identity of the species is very crucial, because you want to manage the right species in the right way. So here I give you a handful example of fishes. Each of them has their own unique identity, and we study that and we provide the data in our taxonomic activities. So in order to get those kind of data, field trips to collect specimens and data is very crucial. I've done a lot of field trip during my career throughout part of Indonesia. Data like the abundance of the individuals and how they can be found and what kind of ecosystem, even like behavior. That's something that I collect during the field work. And that's something that not readily available if you use only museum specimens. So this is an example of different kind of freshwater habitat that I've visited, from streams, waterfall, peat swamp forest, like middle reach of the river, tributaries. And also one of the important part of my fieldwork activities is to get the photograph of fishes in order to get the info about how they look when they're alive, or at least their fresh coloration. Why that data on fresh coloration important? So here I give you an example. Basically, this is what you see when you deal with dead specimens preserved in alcohol. What is left is only black pigment. So they look similar to each other, and it's hard to tell them apart. But once you get incorporated all the colorful information from the fish field photography, it helped us tremendously to tell them apart. So that's why I really highlight this fish photography during the field work. It's very important. In 2018, I start to get involved in some projects with IUCN. So I focus on how to assess the conservation status of different kind of species of fishes. And the terminology is IUCN red list assessment. So probably if you heard about categories like endangered, critically endangered, vulnerable, that is something that we've done in red list assessment. And I get to visit the Maliri Lake system. So as you can see, it is a cascading series of lakes. They are actually ancient lakes that resided in the central core of Sulawesi. And there are three major lakes, Lake Matano, Lake Mahalona, and Lake Tovuti. And this lake system is home to a great diversity of aquatic creatures, including fishes, gastropod like snails, and even shrimps. And they look all stunningly beautiful. So here are some pictures from those lakes. And here are some examples that I managed to get for the photograph of those endemic fishes. Here I give you a clip showing the underwater condition in Lake Matano. So sorry for the choppy video, but as you can see here, there is this cichlid. This cichlid is actually invasive. They are originally from Central America. They are not native to this lake. And here you can see some fishes, small fishes dancing around. Are actually the native species. And there is a significant decrease in their population because of this invasive species of cichlid. You probably have heard about Lohan. That's actually that cichlid that got released into the lake. And they become so abundant that they eat all the fries of this native species. And it's not only cichlid that is invasive. There are more like a dozen species that occur in this lake system that is not native and quite invasive and has given a lot of problems. So as you can see, you probably noticed there's like these yellow fishes. This is one example of the endemic fishes in Lake Matano. I managed to get the photograph. They look stunningly beautiful, yellow. And you can only find this species in Lake Matano. And here, after I collect a lot of data, like threat, the habitat condition, and how they distribute throughout the lake, I compile the data, and then I try to assess the risk using the criteria that already standardized in IUCN. And then you can see here the status of this specific species is near threatened. And you can see here in the map is actually the distribution of that species, Telmaterina opudi. So if you want to check in the Red List website, you can see a lot of the data that we've been compiling and that have been used to determine the risk of this specific species. And you can see here the taxonomy. This is why it's important to tell the identity of the species. You need to know what it is. If you have a wrong name, if you assign a wrong name to different species, then it would jeopardize the conservation effort that we need. Yeah, so that's basically what I've done, and that's highlight the importance of taxonomy in our conservation effort. You need to know the real identity of the species. Thank you.
Great. Thank you so much, Daniel, for such a great presentation. And I'm so envious because I saw a lot of really fun pictures from your field work, diving, swimming, and just watching fish playing around. What a nice activity. Now, I would like to invite our second speaker today, Jessica Dykeman, and I would like to read her bio first. So Dr. Dykeman is a researcher with the Smithsonian Conservation Biology Institute Center for Conservation and Sustainability. She leads research teams to evaluate effects of land use change in highly biodiverse tropical environments and has worked at sites across Latin America and in Africa as well. Her work addresses questions of species and ecosystem resilience in the face of anthropogenic change. Wow, that's a very unique language that I've never heard before, and I would like to hear more about that. And she earned her doctoral degree in biological science from Louisiana State University. Jessica, welcome.
Thank you, Johannes. Thanks very much. I'm putting my presentation in share mode. Can everyone see it okay? Great. Okay. Thanks again for being here. I'm excited that our episode occurs on Earth Week because this is a perfect topic to be talking about during the time of the year when we are most celebrating Earth and celebrating our optimism towards a future that's good for both humans and wildlife. So I'm going to talk a little bit about my pathway or my career in conservation and what I'm doing today. So when I was a young girl dreaming of being a conservation biologist, I thought of this. I thought of field work. And here I am as a very young scientist in the field, taking measurements, observing wildlife, taking samples. And most of my field work has been in Central and South America. So I've gotten to visit places that, had I not become a conservation biologist, I might never have been able to visit. But over time, I realized that conservation has to be more than just field work, unfortunately, for people like me who love field work, and people like Daniel, I think, who love field work, and probably everyone here. All those measurements from the field have to be analyzed. They have to be written up and they have to be shared with people if you really want to make a difference for wildlife. So I have spent more and more of my time with each year doing more of those things. And also, when people think about conservation, they often think about biodiversity, animals and plants. And of course, while saving species and preserving healthy wildlife populations is one of the ultimate goals of conservation, another main goal is healthy ecosystems that can support both wildlife and human communities. And in order for that to happen, we need to work really closely with people. So 10 years ago, I started working at the Smithsonian. And in my research group with the Smithsonian, we really recognized the need for development to benefit human communities. But as we all know, this all too often happens at a cost to biodiversity and ecosystem services, which is counterproductive for human well-being. And you can see that in some of these pictures here. On the top left, we have a road or pipeline that's gone through a forest that causes fragmentation. On the top right, you see what happens when you bring light to a forest for the very first time. You can see all those insects. On the bottom left, we have communities of people who want to monitor their wildlife, but they don't necessarily have all the skills needed to be able to do that. And on the bottom right, we have something that's all too common, which is slash and burn agriculture, where we burn down forests to be able to plant food for people. Well, in my research group, we aim to integrate conservation needs with national priorities for sustainable infrastructure and agriculture development projects. And one of the ways we do this is through partnerships with all kinds of people. And we undertake research that's really based on questions to develop these innovative but practical solutions to mitigate threats to biodiversity in these development projects. So I like to think of myself as a problem solver for nature. So now I'm going to go just through these 4 problems that I mentioned, these 4 challenges that we've addressed with our research. And I'm going to show you who we partnered with and the solutions that we came up with. So this first one is, we worked on a project in Peru where a pipeline was being constructed through a forest. And you can see that that divides the forest into two pieces. And that's not good, especially for animals that live in the trees and need to cross over on either side. You know, maybe their favorite fruiting tree was on one side of that new divide and they can't get there anymore. So we partnered with engineers, with foresters, and economists to develop a solution. And you can kind of see it in this picture here. I'm not sure if you can see my arrow or my cursor, but above where that person is climbing up into the tree is what we call a canopy bridge. So it's a place where bridges or where branches on either side of that pipeline remain connected. So that allows a space for things like monkeys and other arboreal animals, animals that live in the trees, to cross from one side to the other. And we put camera traps up there to see if they work, if animals use them. And that's what my colleague, Tremi, is doing here. She's climbing up in the tree. She's about 40 meters up in the air, installing a camera trap. And they sure do work. This is an anteater, a mama and her baby, crossing in one of those canopy bridges. And we had lots of animals crossing. So that was a solution that we worked with multiple partners to come up with. And it's one solution that can be implemented in forest fragment projects. Another problem is this lighting thing. When you bring big lights to a place that's never seen light before, it attracts all kinds of insects that normally use the moonlight to navigate. Well, this is not good for insects, and it's also not good for people who are trying to work underneath these lights. So we partnered with lighting engineers and construction workers to try to find a solution to this. And we did a big study, and what we found is that there is a kind of simple solution, and that is just changing the light bulbs. If you change the type of light that you use, you can really minimize that impact to biodiversity. But we wouldn't have known that had we not partnered with all these different stakeholders. Now we're talking about slash and burn agriculture. So this is a big problem all over the world. Well, we work at a site in Gabon in Africa, and there slash and burn agriculture is a real problem, and it's causing deforestation and habitat degradation. So we tried to come up with a solution for farmers. How can we work with them to make them not have to cut down the forest? And we, in this case, we worked with the farmers, and we also worked with waste management professionals to develop a solution, and that is biochar. So biochar is just, it's burning, it's basically creating a carbon from waste and then putting it on these fields, and it makes the fields more fertile. So we developed a way to fertilize the fields with waste to minimize the slash and burn agriculture. So now farmers don't have to cut down new forest or they don't have to cut down forest to make way for new fields. They can just fertilize their forest following this study. And again, back to our communities that we work with. This is a community in Peru, and they really want to monitor their biodiversity, especially fish, because fish are a really important resource. And in diverse places like tropical forests in Peru and Indonesia, for example, it can be really hard to tell species apart. So we worked with indigenous communities and data scientists and molecular biologists to develop computer and genetic tools that support participatory monitoring programs with local communities. And so by using technology, by working with many different people, many different stakeholders, we try to develop solutions to minimize impacts on biodiversity of development and create a more healthy and sustainable world for both human and natural communities. And with that, I want to say thank you one more time, Terima kasih, and I'm so sorry. And I will turn it over to Johannes.
Thank you so much, Jessica and Daniel, for very great presentations. Now, remember, we are not done yet with our speakers. We have two more speakers that I'd like to introduce, and I would like to read their bio first. I would like to invite Cody Coltrap. He is the digital interactive designer at the Smithsonian Center for Learning and Digital Access. He serves as project manager for a variety of projects that use digitized museum objects in innovative ways, including virtual or augmented reality and mobile-based application. Cody develops games, graphics, and interactive simulation using Smithsonian digital resources in order to make the research data and stories more accessible, engaging, and fun. So, Cody, welcome.
Thank you so much, Johannes. I'm really excited to share some of my work with you all, and let's get started. So I was told that everyone was sad that this didn't have a sound effect. So let me go back. I'm going to sing it for you real quick. Do 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 do. Yeah, as Johannes said, my name's Cody Coltharp, and I'm an interactive designer for the Smithsonian, and I'm going to talk briefly about how I take the Smithsonian things, stuff like specimen scans and data sets and artifacts, and I combine them with the research and the curation that the Smithsonian scientists like Daniel and Autumn Lynn and Jessica are doing. And I run those through a video game engine to kind of tell their stories through the medium of video games. So I'm really excited to share some of them. This first one is all about supernovas. And one of the things I really, really like about video games is that I can tell stories about things you can't see or witness or experience in real life, and definitely not on a museum floor. This scientist down here in the bottom right, her name is Kimberly Arcand, and she led this team of astronomers and scientists and researchers to visualize this in the top right, a 3D visualization of the aftermath of what happens when a star explodes. So it's amazing, amazing set of data. And she very kindly shared that data with me, and I was able to put it in this game engine and let you, from the very center, see all the different types of radiation that's coming out of this. All the different colors represent different levels of radiation on the electromagnetic spectrum. And it's just a different way to experience this data by putting yourself in the very middle of it. And there's a 3D YouTube video where Kim can narrate what the science is behind it, and it's just fascinating data. And then in this interactive journey through an exploded star, you're able to kind of fly through that data set and adjust the levels of radiation to kind of create your own visualization of a star, which is very similar to what the researchers working on the project do. Give a quick clip of that. So yeah, all the different colors of different levels of radiation. So X-ray, gamma ray, radio waves, et cetera. And really interesting view into what it would look like if you were in the middle of this burst of energy that stretches 17 light years across. You know, it's this huge amount of space. The next project that I want to share, some of you might actually be familiar with this scientist at the bottom right. Her name is Dr. Nancy Knowlton, and she's one of the founders of the Earth Optimism movement. She's been monitoring the oceans for decades. She's just a superhero. I worked with her to kind of tell some of the research that she's been doing over the years in an interactive called Secrets of the Sea. And in the interactive, you take the perspective of a fish, and you're able to kind of swim through the nooks and crannies of a coral reef. And you start out, it's totally bleached and totally dead. But the more that you explore and the more of the different organisms that you discover and see how they all connect, the more that the reef begins to come back to life. And so she narrates all the really interesting stories that the fish, the types of interactions that the fish have and the organisms have with each other. And it's I was really fascinated by her work and the research that she does. And then this last project is one I'm working on right now. It's still, you can see it's still a little rough. It'll get there. But this is the research of a colleague of mine at the Tropical Research Institute named Dr. Rachel Page. And she studies the predator-prey interactions between this Tungara frog and a fringe-lip bat. And so I kind of created a cute version of what happens between them, but the frog makes a very certain kind of call to attract a mate, and the bat has evolved to hear this call very, very well. So the poor frog has to make the decision between trying to attract a mate and trying not to get eaten. So it's a 2-player game. I'm working on it right now. It'll be ready very, very soon. And so those are the 3 projects that I'm sharing with you. And again, I'm so excited to be talking with you all, and happy to hear any questions that you have. And back to you, Johannes.
Yeah, thank you so much, Cody, for that sound in the beginning as well. And for you, I'm excited to talk about your project that you're currently working on. And last but not least, I would like to invite our speaker, Dr. Autumn Lynn Harrison, but I would like to read her bio first. So Autumn Lynn is a research ecologist with the Smithsonian Migratory Bird Center and the program manager of the Migratory Connectivity Project based at the Smithsonian Institution here in Washington, D.C. She studies the migrations of marine and coastal animals like seabirds, shorebirds, seals, and sea turtles, and applies this research to conservation and management. She had done some field work in many different places, for example, tracking the migrations of seabirds from Alaskan Arctic and seals in South Africa. And she earned her PhD in ecology and evolutionary biology from the University of California, Santa Cruz. Autumn Lynn, welcome, and please.
Thank you so much. I'm really excited to be here. I'll share my screen now. Yeah, so thank you for inviting me to Earth Optimism TV. I'm really excited to talk with you all today about how we use our science to design a future where we are saving species. For the last 20 years, I have studied migrating animals as a marine biologist. These are animals that make regular large movements across the earth. Fur seals in South Africa, seabirds 300 miles north of the Arctic Circle, and the migrations of Indonesian leatherback turtles seen here. The paths they take them through over 30 different countries through their migrations. And maybe some of you have even seen them nesting on your beaches. Indonesia is a very important place for leatherback turtles. And I thought it was just so amazing how these animals connect us in the United States to all of you in Indonesia. I really love studying animal migration. Animals migrate to find food. They migrate to escape bad weather and go to good weather, and to find places where they can raise their young. And to think that we share this species across international borders is just so inspiring to me. They make this long journey in hopes that the places that they love will still be there when they arrive. And there is nothing more hopeful or optimistic to me than animal migration. I work at the Migratory Bird Center, which is part of the National Zoo and Conservation Biology Institute at the Smithsonian. And we were founded by an act of Congress in the United States in the 1980s. We are dedicated to understanding and protecting migratory birds. And in my job, I mostly study shorebirds that are found along the coastlines or seabirds that make their lives over the ocean. This Arctic tern is a very small seabird and makes the longest migration of any animal in the world. It migrates from the Arctic region to Antarctica, so from the top of the Earth all the way to the southern point of the Earth. It can be really challenging to protect these species across so many international borders. As Jesse said, a lot of what we do is work together with other people to collaborate and save species. So I really work to make sure that my science is used for conservation, and I spend a lot of time sharing what I have learned, either by writing papers or giving talks or collaborating with artists and educators like all of you in the audience. These days, a lot of my work to study where animals go and why they go there uses satellite tags. We can attach small little tags to animals, and then satellites orbiting the Earth report back to us the animal's location. And here I'll show you a series of videos about how all of this works. First, you have to catch the animal. Here I am working in the Arctic tundra of Alaska and using a trap to catch a shorebird at its nest. This is a male black-bellied plover. And I'm wearing a mosquito net because in the Arctic in the summer, it's just alive with life. And that's why migrating animals go there. I then attach this small little tag to the lower back of the bird using a harness made of ribbon. This bird wears the tag over its legs, so it doesn't get in the way of flying. And the black portion on the top of the tag is a solar panel to keep the tag charged. And some of these tags can last for 6 years with the power of the sun charging the tag. Then away the bird goes to share its migration secrets. This video was taken in late June in Alaska, and you can still see the ice cover there over the pond. This bird had a really beautiful nest site with a full waterfront view. And here are the results of some of my research. These lines represent flight paths of this shorebird from the Arctic, where they nest, to the tropics, where they spend most of their year, connecting us really across their Earth. And now you can see the flight paths start to go back north. That's happening right now. These birds are migrating back to the Arctic as I'm talking this morning to go back to their nest. But then when I'm not in the field working with animals, most of the time I am at my computer getting sucked into data analysis and writing and making all of these products to share. I use the data I have shown you today to identify important places to protect for migratory species. I often work with partners in these important places so they can apply what we have learned. And I've also contributed my science to international treaties. I was invited about a year ago to present the results of some of my research to the United Nations during their first General Assembly to create a new ocean treaty. They asked me to share information about how I use tracking data to show which countries are responsible for protecting marine animals, how much time each species spends in different countries, and also in the places in the open ocean where there is little to no protection, species like your very own leatherback sea turtle. And so working in conservation every day, I see how migrating animals connect us across borders, how technology is revealing this, and how they really provide us a reason to work together globally to protect the Earth. Thank you so much, everyone, and I can't wait to hear your questions and to chat with you.
Yeah, thank you so much, Optimlin, for a very great presentation. And I'm excited to talk more about the migration of animals with you. And welcome, four of you. We have, as I mentioned before, we have a full house in our last episode today. It's a surprise for everyone. So this has not happened very often. So again, welcome. So I would like to kick off our conversation today, since our theme today is career in conservation, or just in environmental protections field. So I wonder if working in this field, in the conservation field, researcher, ecologist, education field, was your childhood dream? And if not, what was your childhood dream? And what was that moment that inspired you, that you say, like, I want to work in this field. I want to work in observing animals, observing birds, and things like that. And maybe I can go with an order. Maybe I'll start with Autumn Lynn and Cody, and then Jessica and Daniel. Autumn Lynn, please.
Thank you so much for that question. I grew up in a very marshy, natural place. And so I was always playing outdoors. But I would play outdoors in the little dresses that my mom would make for me on the sewing machine. And so I'll say I went back and forth between wanting to be a fashion designer and wanting to be a biologist. But it was always there at some point. And ultimately, I went that direction, but I still love being creative in the work that I do, and being colorful too.
What about you, Cody?
Yeah, I mean, I think it's pretty close, actually. I grew up loving video games. I played all the time. I was from somewhere like in the middle of nowhere, so I didn't have much to do, and so I played a lot of games. And I wanted to be an artist when I was, a little bit older, and I think I kind of am doing that. I think that's kind of rare for people to have a vision. It's different than I imagined, but in my mind, the people, Nintendo was some magical land of wizards that were creating these things like with magic, and as you get older, you see how to do some of the things, but. Yeah, I think I'm pretty close. I'm not too far off.
Yeah. What about you, Jessica and Daniel?
Yeah, I grew up in a more urban environment, but I always sought out nature. We had these little creeks or streams that would run through the area, the city that I lived in, and you could always find me down there trying to play with tadpoles and snakes and all kinds. I found nature wherever I could find it, even in urban environments. And so I knew that I wanted to do something with that, and I wanted to be outside, and that's what I wanted. But I didn't know that there were careers like this out there. I had no idea. So the closest thing that I could imagine in my young head was to be a veterinarian. So for a long time, that's what I wanted to be. I wanted to be a veterinarian because, well, that worked with animals, so that was kind of close enough. But then as I got older, I realized that there were other opportunities where I could be what I really wanted to be and do what I really wanted to do.
Great. Daniel?
For me, I mean, I grew up wanting to be an architect because I have a great passion for virtual art and all the architecture thing. I never thought about being biologist. But of course, since I was a kid, I have a strong passion for fishes. I mean, I like to keep fishes as my pets and my tanks. So when I started college, my first choice was to be an architect. And the second choice, because I got good mark in biology, so probably for the second option, I would just pick biology. But then it turned out that I got accepted in the biology department, although another school accepted me as an architect. But then my father told me he wants me to go for biology because it's in a, what do you call it, like a better university. So I think I will follow my father's what he wanted that time. But it turned out that in my second year, I got to learn evolution in this evolution course. That's totally changed the game, and I become so how to say, so into process of how things become diversified. And then I see more. I did more field work to like nature side of Indonesia in Java, and since then it become like my main passion. And of course, in taxonomy, you can still apply your art passion, because usually we, as you see, even like photography is like part of visual arts, and I find it very cool and also interesting. And usually when you try to describe species, you also need to provide like good illustration, and it's something that I can how to say, contribute from my art passion.
Yeah, thank you so much for sharing all your stories. Seems like everyone's pretty close with their childhood dreams. I want to be a dentist when I was a child, and I'm not anywhere close to become a dentist right now. I'm studying international relations and social entrepreneurship today. So I'd like to go to Cody and Jessica first. Working in this field, it is very important. It is very important because you have to work with people from different backgrounds. So in both of your field, who did you work with, and how did you find having that interdisciplinary skills, working with people from different backgrounds is very important in this field. Maybe I'd like to go to Jessica first and then Cody.
Yeah, that's a great question, Johannes. And when I first started off in my career, I didn't really have this idea that I would have to work so much with people. I thought, oh, great, I just get to work with animals and that's going to be wonderful. So even in my training in school and in graduate school, there weren't really many opportunities to learn about how to communicate with people outside of my field. So it was really learning by doing. And when I came to my job, I had to start working with the private sector. So I started working with companies and industry that was doing extractive development activities. And, the traditional mindset of conservationists has been like fighting against that. And in some ways, that's an important thing to do, because we can't develop the world. We need to protect and preserve at least half the world. But a lot of that development that is happening can be done in a best practice way. So what's really important is to have dialogue and at least talk. If the two sides are not talking, then nothing good is going to happen. So I just had to learn the language of the people that I needed to work with. And I had to kind of teach them my language. So that's more or less how that went for me.
Yeah, that's great. What about you, Cody?
Yeah, I'm trying to think of a similar kind of situation. I've been really lucky with the people that I've worked with at the Smithsonian, because I've worked with many scientists. Often, people are really specialized in certain things. Like, I'm not specialized in communication. I develop games and coding and do artwork. I'm not a public speaker. Often scientists are the same. They are researchers. They're very good at tracking data. They're very good at the field, but maybe they're not great at communication. But at the Smithsonian, it's been so easy because everyone has been so good at communicating what their work is. If you look at Kimberly Arcan give a talk, it's spellbinding. Nancy Knowlton is famous for a reason. She can tell the story of why it's important to protect the oceans. Rachel Page can get anyone super, super jazzed and interested in these tiny little Tungara frogs. For me, that has been really, really easy to work with the scientists and to tell their stories because they've been really good at communicating. Some of the more difficult things that I've been juggling is when you're developing a game, there's many, many facets of the game design. So, you have artwork, you have interactivities, you have coding, you have music, you have sounds, you have UI design. And so if you're working on a large team, it is hard to kind of bring all of these elements together and all of these different people or different specialties together to make something cohesive. So that in that sense, it is, there's a lot of different things to kind of join together to make one product that does tell this really cohesive story.
Yeah, thank you so much for the answer. Like you both said, communications, conversation, and dialogue is very important. Now I would like to go to Autumn Lynn and Danielle. So Autumn Lynn, in your experience, you went and share your data and your research to the United Nations or people in a high policy-making level. So Autumn Lynn, from your experience, and Danielle Tobin, from your publications and research, what were the challenges that you faced when you sharing this knowledge, this learning, your experience to the people, and how did you navigate through these challenges? Maybe Autumn Lynn first and Danielle.
Sure, thank you. It's a good question for a scientist because the United Nations is kind of this ultimate policy level with experts from around the world in stakeholders and their own country's needs. And so when I was invited to share my science, I was given 8 minutes only to distill all of this information. And it was in that big General Assembly room where everyone's wearing translators over their ears and you can see the translators in the windows. So first of all, that experience of being a scientist and looking up at this room and seeing all of the placards of the countries and their translators was amazing. But I knew that I had to change the way I talked about my science for this audience. And so rather than showing a lot of words or a lot of data, I created infographics to distill the main messages of the science and was given slides. But I think the key point was to figure out the main messages I need to convey, to use very straightforward statements and take-home message numbers, and showing all of this in a kind of designy infographic way. This is why having Cody on board at the Smithsonian is so important for us to be able to share our science as well. But definitely there is some translation that has to happen to share our science in the policy arena.
Yeah, definitely. That's such, especially with a very complex Latin name of the species. It's quite challenging communicating those. What about you, Daniel? I think you're muted.
Yeah, so
Perfect.
it's good that I have the chance to get involved in this IUCN rat list assessment. So I get to assess so many fish species. And then, but again, how to say it? Sometimes even in the public, the awareness become higher because they now notice, well, this certain species is critically endangered. But then I don't know, probably once the data is there, the categories is there, published for the public, sometimes I feel, how to say it, the need to encourage the stakeholder in Indonesia, even the government side, in order to take that message more into their policy. And I think the problem for me is probably I need to go further and try to reach them more instead of just, I already published this data, but then I feel like something missing, probably it would be great if I get more network back home and then try to say the message of this the data, and so there will be more real thing or like a policy coming from the government, something like that.
Yeah, thank you so much for all of your answers. And I saw in the chat box there are so many people asking questions. And we're gonna go to the question and answer session. But first, I would like to lead a very fun activity where we all will be playing internet quiz. So I'm sorry, I'm muted. Now I'm going to share my screen and everybody can see my screen. Give me 5 seconds. Right. Okay, I'm ready to share my screen. Okay. So what you guys need to do is go to kahoot.it, and our team members will put the website link in our chat box. And then once you get into the website page, you can go to you can enter the game pin 904485. And for speakers, you also can join if you want. Although I know that you are the one who designed these quizzes, probably. All right, we have 6 people. I'm gonna, I'll wait 5 more seconds before I start the game. All right, we have people joining. Okay, I think I can start now. Okay, 3, 2, okay, it seems like I want to start, but people still joining, but I'm gonna make an executive decision now. Okay, question number 1. Oops, not yet. It's multi-select, so you can choose more than one answers. Careers in conservation can involve fish, people, birds, water. And you have like 7 seconds. Of course, everything is important. It involves everything in the option. Okay, we have Mario. Question number 2. It's multi-select as well. Educators can include conservation in their curriculum by doing what of the following? You can select all that apply. First, increasing informational and interactive resources, focus on conservation, discussing ways to achieve conservation goals with students, communicating conservation goal with students, encouraging an earth optimism approach. Of course, everything is correct. Question number 3. Again, it's multi-select. What is a good way to support conservation efforts? Be an earth optimist, avoid communicating conservation goals for the future, be passionate about the field, and be excited about the field. These are pretty easy answers. All right, so everything is correct except the avoid communicating conservation goals for the future. Yes. Question 4 out of 5. What fields of study can help someone in conservationist field? Biology, environmental science, education, all of the above. Of course, all of the above. Everything is important. Okay, is it true or false? Anyone can be an earth optimist and contribute to conservation goals. We have 5 seconds. Of course, it's true. Are we going to see who's the winner of this game? Okay, Ikan Cupang. All right. I'm going to stop sharing my screen and all right, thank you so much, guys, for participating. Now we're gonna go to the question and answers with our speakers today. I know that you guys already have like thousands of questions that you would like to ask our speakers today. So maybe I'd like to start by looking at the question list. So maybe I'd like to go to Jessica and then Autumn Lynn. So question from Yati Sada. She asked, as a teacher in elementary schools, what can I do for helping the earth? Can I just ask the students to save the earth by planting the trees and throw the rubbish to the litter bin? Anything else? So maybe the questions is what can educators do to inspire their students to like pictures that career in conservation or career in ecology's field is something that can be an option. Yeah. Autumn Lynn, Jessica, and then Autumn Lynn, please.
Hey, well, to inspire kids that want to be conservationists, I think just identifying kids that have a passion for conservation or have a passion for the natural world and fostering that and trying to find ways to get them involved in activities that can be directed at conservation. But I also think that it's really important to teach all the kids, like what she mentioned, planting trees is important, throwing litter in the rubbish bin is important, and also making kids aware of where the resources that they use come from. So where does that electricity come from? Where does that water come from? Where does their food come from? And for some people in some communities, that's really clear and really straightforward, but especially kids that live in cities, a lot of kids have no idea where those things come from. And the fact that we need biodiversity and we need healthy ecosystems to produce those things. So I think just creating that consciousness helps and can make responsible adults if we teach kids that when they're young.
Great. Autumn Lynn, please.
Well, I mentioned one simple action in the chat that is very easy to do, and that is when you're outside, if you see a bit of trash, pick it up. And I do this all the time, especially on beaches, because anything on a beach or our rivers goes right into the ocean ultimately. So coming home with pockets full of bottle caps instead of shells is kind of my way of living these days. But I'll share another story from when I was a kid. I already loved nature, but I think what really gave me the power as a child, as a student, to know that I could make a difference was a teacher that started, it was called a water monitoring program, but this could work for monitoring your backyard or monitoring a park, and just having us go out regularly, make observations about this place and how it changes over time, the birds that you see, the flowers that you see, and maybe you start to care about it a bit more. It becomes yours. You want to protect it. I had my dad come out with me, so getting the parents involved. And I think that giving power to students to really be kind of in charge of a place starts to transform your mind about caring for the earth. And so thinking of ways that you can really empower the students to feel like they are the protectors of this one small place in their life starts to kind of zoom out to the whole earth and can really make a difference.
Yeah, thank you so much for your answer. And Autumn, I want to, there's two questions for you from our participants. So it's from Ari and Agum. So first question, since I think everyone's interested in the birds research that you were doing in the past. So of all the birds you've studied, which one has the most interesting pattern of migration? Is it possible if some of them get lost or decided to stay in particular place? And second question from participant is, has geotag bluefin tuna that migrate ever been caught by fishermen? What happened with the fish if the tag is being caught by the fishermen? Yeah, very good questions.
Sure.
Autumn Lynn, please.
I'll start with that one because a story I didn't tell in the chat I'll share as well. So for the tuna, we actually tagged the fish in partnership with fishers. So it's not surprising that for a schooling fish, these tuna stay together in the hundreds or thousands, they migrate together, that if we're catching the tuna in partnership with fishermen, then they'll also get caught at some point. And over 70% of the tuna that we tagged were ultimately caught in fisheries. And that was a very high number, higher than we thought. And it meant that out of 300 tuna that we tagged, only 11 were recorded to make their full migration across the Pacific Ocean from California to Japan, because they were caught along the way. And the fishers receive a reward if they catch a fish that is carrying a tag. They may get $100 to $500 for calling a phone number and reporting the tag. So that's how we were able to get the tag back. All of the data are on the tag. Those fish tags don't transmit to a satellite. So we have to get the tag back physically to get the data. So the reward for reporting the tag is a monetary one. And then I'll say we've also had cases where a shark ate a seal that was carrying a tag. And so there are interactions between tagged animals where a tag or a salmon or a shark is tagged, a seal is tagged, and there's interactions between them, and we can see the tags blink out when the seal gets swallowed. And then in terms of the most interesting bird, I'll make this short. Some birds do get blown off course due to hurricanes, and you'll see seabirds in the middle of the continent. Young birds are often more exploratory than adult birds. They don't have to come back to breed, so they might take bigger trips and try their luck at new places. So sometimes you'll see adults going to different places than young. And for my favorite bird that I've started studying at Smithsonian is this tiny little gull. It's the cutest thing. And its feathers are pink because it eats krill and crustaceans that turns them pink like flamingos. But it lives its whole life in the Arctic. So it actually migrates around the Arctic Circle, which is very unusual for a bird to spend its whole year in the Arctic. And when I first saw one flying against the Arctic sky, it looked like this little pink light bulb that was just lit from within against this dark sky. Oh, it's just the best bird.
Yeah, thank you so much, Autumn, for your answer, and make sure that if you happen to just catch a fish with a tag before you migrate the fish to your stomach or to your kitchen, please give back the technology piece of the tag to our researchers, because it is very important, the information inside the tag. Now I'd like to go to Daniel and Cody. So there's questions for you. So to Cody, thank you from Agong Alexander. Thank you for showing animated videos. How long do you usually work on one game, and how big is your team? And can we access those games for free? Maybe if you can talk a little bit more about the process. And question to Daniel, what makes you interested in researching freshwater fish? How did you start? So maybe Cody and then Daniel.
Yeah, those are really great questions, because I do get asked that a lot of how can I do this with my work, right? How can I make my work more interactive, or how can I add some feature to it? And, what's the size of the team? How long do these take to develop, or what's the budget, et cetera? So depending on the game, I think in general, it takes me about 6 months. And this is mostly because I don't have big teams. At most, I'm working with maybe 3 or 4 people if I have the budget. So for example, with the Secrets of the Sea project, I had some 3D corals scanned by the Smithsonian. So I already had some assets going into it. But I had to design some assets in 3D, and I had to hire an animator to take those 3D models and animate them around the scene, or to help me do some of the animation, because there's a lot of animations in that one. So anywhere between just me working on something to a team of 3 or 4, and about anywhere between 6 months to a year. Like with the Journey Through an Exploded Star, it was just me, and so that took a lot longer. So the more people I have working on it, the quicker it can be, but that's all dependent upon the budget. As for whether or not they're free, absolutely. The most important thing to me when I'm developing something is that I have it accessible to a broad range of a spectrum of technologies. So what you're seeing is all the games you see are just available through the internet. You just go into and I'll put them in the chat, the links. You just need a regular browser. You don't need to download anything. My big audience is schools, so I know most schools don't let you download games, or don't have special software to play them. So you just need a regular browser to play them. But I also provide alternatives to even that, where you can watch videos on YouTube and get the same kind of experience, or even printing it out if you have no internet, no electricity, if you're out way far out, and you just need something physical for like a piece of paper that the kids can play with. I also do print and play type board games that you can print in advance and bring it into the different school populations. So very, very important to me to present the information in as many avenues to getting the material as possible. But very good question.
Thank you.
Daniel?
Okay, so the question, why do I study freshwater fishes? This is something that people have been asking me a lot, because I'm from Indonesia, and this is like the largest archipelago country with more sea area. But why I ended up like learning freshwater fishes? Well, probably first because I think it's more like my personal interest, because since I was a kid, I like to go to the river and try to collect fishes, like something that close to my home. But then again, it is interesting because if you compare the volume of water throughout the world, only 3% is fresh water. But then again, out of there are probably like 35,000 species of fishes totally in this world, but like more than 50% are freshwater. So that tells something. I mean, the diversity of freshwater fishes is so amazing for me, because why? One time I told people that if you go to Bali, and then you will find the same fishes as if you go to like the end of the tip of Sumatra, like in Aceh. Even if you go to Papua, you probably have the same fish assemblage. But when it comes to freshwater fishes, different river basin can have its own assemblage of fishes. So there are high endemism of freshwater fishes. And it has something to do with the process of the evolution. So whenever you have like mountain range that kind of like, how to say it, like go around the basin. So the process of evolution in this fish assemblage in that specific basin will be separate from the other basin that separated by the mountain range. So, for example, like if you go to West Kalimantan, there is a big river, Kapuas, and you won't see the same fish assemblage in like Barito, which is the other river basin in the central Kalimantan. Even though like in the upstream part, they kind of like connected, but still separated by the mountain range. So it's more like first the diversity, and also again I like to go to different part of the rivers to collect, and you will find different fish species. Even like if you go to the stream, like in the upper part of the river, you will have a different assemblage of fishes, and then you go more to the middle, there are more fish diversity there, and also different species. So how to say it? Like probably it's more like the diversity, and it has something to do. We call it the biogeography of fishes, and how to say it? Like for example, like in Borneo, there are a lot of area of endemism. They call it area of endemism because in that specific area, there are like tons of fish endemic only to that, for example, like river basin. Yeah, so it's just how to say, like fascinate me to deal with this kind of diversity in like different part of geographical terrestrial area.
Thank you so much for a very good answer, and also for Jessica for putting down the meaning of endemism. I hate to say that we have to wrap up this session very quick, but I'd like to ask final questions and maybe ask your final thoughts for our participants. What's the easiest and the most difficult part of your job? That's the first question. And the last is maybe what are the things or advice that you'd like to share to our participants today to, like, for example, making sure that their students stay motivated and looking at a career in the conservation field as one of their options. So maybe I'd like to start with Jessica, and then Autumn, and Cody, and then Daniel.
Ooh, I have to go first, huh?
Lucky you, Jessie.
Yeah, that's a complicated question. What's easiest and hardest about my job? It might be the same thing in some ways. I mean, so what is easiest for me is to love my job, because there are so many different aspects of it. You know, being a conservation biologist, you get to do new things and meet new people and see new creatures all the time. And so that really is inspiring and motivating. And at the same time, that can be a hard part of the job, because you have to learn new things and learn how to talk to new groups of people that you haven't communicated with before. So what is most exciting is also most challenging. And I think I will leave it at that. And to inspire kids, I mean, I would just say to foster the excitement that they already have, and let them be curious and let them be adventurous. And Autumn Lynn told some great stories about how she was motivated and inspired when she was little. And so as teachers, you are in the best position to be able to do those things. Thank you for doing it.
Great. Please.
My turn. Yeah, I'll echo Jessie's sentiment that the easiest part of my job is learning new things, working with animals, seeing new places. So, you know, all of that part of my job is just so easy and wonderful. And I think as a conservation biologist, maybe the hardest thing is not always having the power to make the changes that I want to have happen. Being a scientist instead of a politician, not having that decision-making authority, that can be difficult to really observe an environment over a long period of time and see these changes and want to make the world a better place. Sometimes I don't feel like I always have the power to do that, but then I return to what I do have the power to do, and that is to share my science, share my knowledge, make myself a bit uncomfortable by stepping into those policy places, and that's pretty nervous as a scientist to do. So that's the hardest part of my job. And for advice, I would say just really keep learning, stay passionate, don't give up. You can make a career in this field, and there are so many options these days to do that. So I think, yeah, just don't give up. I mean, that's kind of trite, but but keep learning, keep sharing your knowledge, and if you're really excited about what you do, then other people notice that as well, and you can make a difference and get a job at the same time.
Thank you so much for your answer, Cody.
Yeah, lots of the same sentiment. For me, the easiest thing by far is to bring a game or an interactive into a classroom and watch the kids play it, watch their excitement, watch their face light up, or or not. They say, "Oh, this is boring," and it's like back to the drawing room. Maybe that's the hardest part. The hardest part is definitely trying to figure out what. So sometimes the ideas that we're presenting are really complex or sophisticated or have a lot of facets. And so it's trying to distill the main idea, the main message down to something simple enough that a fifth grader can understand, or even a kindergartner can understand, right? So for sure, it's trying to make the message that we're telling accessible. And that is definitely something I struggle with all the time. And then also the hardest thing is getting on Zoom and giving talks. Come on. As for motivating, the whole reason why I've kind of chosen games as this medium for telling these stories is that I have found that the more that you understand something, the more you're engaging with it, the more you're working with it, the more you care about it. And the more that you care about it, the more you want to protect it, the more that you want to make it your own. And so for me, I think that this medium is one that's really good about getting the players to engage with and care about and then want to protect by learning more about it.
Daniel, please.
Right.
Last but not least.
Yeah, so pretty similar to the others, what they said. So I guess when it comes to the easiest part of my job is when it gives me great excitement, which is like going to the field, discovering new things, collecting more fishes, and then like getting more data. But again, when it comes to something that's difficult, probably, how to say it, like at the end of the day, you need to analyze your data. And sometimes I'm not really good at a computer thing, like a software to analyze my data. But I think that's part of learning process. And sometimes when you manage to learn more from that kind of software, you get that also excitement. But again, when you need to start that, it's something else. And also probably, also about how to communicate our science. I think science communication has become important today, and sometimes because, at least for me personally, sometimes I'm just too focused with the specimens and then all the microscope and all the specimens, and I don't really interact with a lot of people when I was in the museum, especially during the pandemic. And I guess it would be good if I spend more time to get more public outreach. Even like this kind of opportunity is a good way. And what else? The question again? the advice.
Recommendations, final closing statement.
Oh, okay. Well, yeah, I think how to say it, to make biodiversity interesting is probably we need to know how biodiversity is important to our life, how it interconnected to our own life, and how it affect our daily life. And sometimes, how to say it, like a single species is very important. Even sometimes we kind of like, how to say it, like don't see the function of certain species. For example, like tiny fishes, what that make our life affected. And then I guess probably we need to, I think I would like to highlight why each species is important in our life, because it has its own ecological role in a bigger ecosystem, and it affects our life even if it's not like directly. I mean, sometimes I just use analogy of a company with different kind of staff, and once a staff is not working properly, the whole company become probably like less functional, and that's the same with ecosystem. So I guess how to appreciate each species in the ecosystem is something that probably kind of like trigger more interest among the educator, when they realize that even like a tiny insects in your backyard that seems negligible, but they have their own role in ecology. And that's why it's important for us to try to conserve them, to keep, to work on their conservation. I think that's pretty.
Yeah. Thank you so much, everyone, for such a wonderful presentations, and also stay engaged in our conversation with our participants today. One takeaway as a moderator I would like to share is stay engaged in the dialogue and the conversations around this field, and be creative, and always be optimistic. I forget to mention that when I learned about Autumn Lynn's work, I came to very creative pictures that she put together Doctor Strange with a species of bird, and that encouraged, that motivated me to search more why there's Doctor Strange of Avenger and there's this species of bird. So be creative and stay optimistic. And I would like to wrap up this session by showing you another video of Smithsonian Institution. Please. Thank you so much, everyone. I'm really sad to say that this is our last session of Earth Optimism for Educators this semester, but I'm very optimistic and hoping that all these 5 sessions will inspire you to go out there and make change. Now I'm like to give it back to James and see you around. Bye-bye.
Thank you so much to all our speakers, Daniel, Jessica, Cody, and Autumn, along with our moderator, Mas Johannes, for today's very informative session. Earlier in the event, we asked our audience members a question. True or false, 200 gallons of water are wasted every day by average home users? And the correct answer to that is true. The average household wastes 200 gallons of water every day by washing dishes, taking showers, etc. Congratulations goes to Putra Aditya from Facebook for answering correctly. And thank you to everyone who has participated. Don't forget to tune in next time for another chance to get a shout out from us. I'd also like to remind all our audience members of our giveaways, the 5 bicycles for the 5 lucky people. If you still want to join, visit our link at bit.ly/payitforward for more information. Now you may be wondering, how could I develop an awesome idea for a place like this? It's very easy. All you need to do is go to our website at www.atamerica.or.id, select create a program and click collaborate with us. All event proposals coming to us will be reviewed and your event might be featured here soon. You can also subscribe to our newsletter for all our weekly updates. And that wraps this episode. It's been fun, but we have to say goodbye for now. Thanks again everyone for joining. My name is James, and I'll see you at the next Ed America TV episode. Goodbye.